Our sister planet Venus, because it's almost the same size of our Earth, and its 10 mysteries. The surface of Venus is completely inhospitable for life. It's barren, dry, it's crushed under an atmosphere about 90 times the pressure we have on our Earth. It's also roasted by temperatures twice as hot as the oven, but was it always that way? Could Venus once have been a twin of our Earth? Could it have been a habitable world with liquid water oceans? It's one of the many mysteries associated with our shrouded sister world. 27 years passed since NASA's Magellan mission last orbited Venus. That was NASA's most recent mission to our Earth sister planet, and while we have gained significant knowledge of Venus since then, there are still numerous mysteries about this planet that remain to be solved. NASA's Da Vinci, the Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, Da Vinci for short, the mission hoped to change that. Then these are the mysteries of Venus that NASA scientists are still grappling with. Did Venus ever host life? That's a big question. Was there ever life? And if so, what sort of life? Was it microbes that resemble simple life on our Earth, or like nothing we've ever recognized? Venus is no exception. The community speculated about the possible life on Venus, but until we know whether Venus was ever actually habitable in the past, it's difficult to say much more beyond those speculations. To determine whether life was ever possible on Venus, we first need to understand the past environment on Venus. That involves studying the atmosphere, the geology, the history of the planet. How did Venus and Earth come to be so different? Venus and Earth are similar in size and density, so hypothetically these planets could be very similar, but yet they aren't. They're strikingly different. The air pressure at the surface of Venus is 90 times that of Earth. Venus rotates on its axis backwards compared to all the planets of our solar system. How is that possible? And the surface of Venus is over 900 degrees Fahrenheit, over 428 degrees Celsius, and it makes it the hottest planet in our solar system, hot enough to melt lead. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. This extreme heat on the surface of Venus is due to carbon dioxide atmosphere with thick clouds of sulfuric acid, which could have resulted from a runaway greenhouse phase earlier in Venus's history. So what happened? Was Venus always so inhospitable? Why are we so good and they so bad? That's the central question. The evolution of Venus through time may help us understand processes that govern global scale changes in the planet's environment, including evolution of the planet's habitability. How did Venus form? Even this basic question about the origin of Venus is still a mystery. It's amazing to me that we don't know whether Venus formed from the same early solar system materials as did Earth and Mars. Said Getty, he said, we still don't know whether Venus was bombarded by comets and asteroids rich in water the way Earth was. These comets and asteroids that bombard our home planet are considered to have been an important source of water for Earth, and understanding the delivery of the water to Venus is important for evaluating the potential to host oceans in the past. What was the atmospheric composition at Venus? We don't know the chemical cycles that provide clues to how it was evolved and the role of these chemical cycles in Venus's history. These unknown are fingerprints that have been missing for a long time. And how were the rocks in Venus formed? The last spacecraft to successfully descend through the atmosphere and land on Venus was the Soviet Vega 2 mission. That was back in 1985. It survived for 52 minutes on the planet's inhospitable hot surface on the night side of the planet. At its landing site, it was surrounded by basaltic plains that were formed by volcanism, but some highland regions on Venus are thought to be different. So the surface of Venus remains quite the mystery, especially in regions beyond the volcanic plains. How much water did Venus have? Liquid water is essential for life. We can't assess Venus's past habitability without knowing how much water Venus may have had and when and how it lost that water. Scientists can use the bulk chemical composition of rocks found on Venus to unravel the mystery of the water on the planet. Garvin says, if we discover granites in the mountains of Venus, then we can infer they must have involved large amounts of water in the Venus crust to allow them to form as they do on Earth. What is the nature of surface activity on Venus? Scientists are still making discoveries to understand whether Venus ever had Earth-style plate tectonics and how those mountain-building processes are similar or different from Earth's. Earth's crust hosts a network of relatively thin plates jostling around the planet's surface in constant horizontal motion. If similar plate tectonics exist on Venus now or in the past, the planet's crust must experience movement of crustal plates over geologic time, mid-ocean ridge volcanism, volcanic activity present at oceanic boundaries between two plates, and subduction, the movement of one plate sinking under another plate. So the history of Venus tectonics is still an active area of research, with many plate tectonics with laterally moving blocks of crust, while others hypothesize that this period in Venus's history is long in the past, perhaps when liquid water was either at the surface or abundant within the crust. Another key mystery about the surface of Venus is volcanism. All planets must get rid of their internal heat, and Earth's method of doing so involves volcanism as an associated process. Scientists are still speculating whether the surface of Venus is currently volcanically active and to what degree eruptions occur today. What do the mountains look like on Venus? Previous Venus landers, Venegra and Vega, have taken photographs of the Venusian plains after landing on basaltic regions of the surface, and Da Vinci cameras will snap the first ever high-resolution aerial photos of the mountainous tessera surface as a probe descends over the rugged Alpha Reggio Highlands region. Now, are there Venus-like planets beyond our own solar system? For example, rogue planets and exoplanets. Well, we've already found them, and we just sent the Lucy spacecraft a couple of days ago to look at the gas giants Jupiter, Saturn, Neptune, and Uranus, plus the Kuiper Belt huge objects and the Centaur-type comets and asteroids, which are like little planets. So we've already found them. We found something concerning a rogue planet beyond our solar system, which is about 13 times the size of Jupiter. Now, scientists are excited about the idea of taking what we learned from Venus, applying it to exoplanets, that is, planets outside our solar system. Venus-like exoplanets are expected to be a common type of planet observed by the upcoming James Webb Space Telescope, and better measurements of Venus may help to understand these distant worlds. New mysteries we haven't even thought of yet. One of the most exciting aspects of planetary exploration is discovering new mysteries we can't currently anticipate. Those new mysteries we can't yet imagine are what we're looking forward to the most. And this was from NASA's Goddard Spaceflight Center, and the video is from NASA Goddard Creative Commons. Please leave your comments and thank you for your support.
The surface of Venus is completely inhospitable for life. Barren, dry, crushed under an atmosphere about 90 times the pressure of Earth's, and roasted by temperatures 2 times hotter than an oven. But was it always that way? Could Venus once have been a twin of Earth, a habitable world with liquid water oceans? Here are 10 mysteries of Venus that NASA scientists are still grappling with. Did Venus ever host life? To answer this question, we first need to understand the past environment on Venus. This involves studying the atmosphere, geology, and history of the planet, something NASA's Da Vinci mission plans on exploring in great detail. Why did Venus evolve so differently than Earth? Venus and Earth are similar in size and density, and yet they are strikingly different. Air pressure at the surface of Venus is 90 times that of Earth. Venus rotates on its axis backwards compared to the other planets in the solar system, and the surface of Venus is over 900 degrees Fahrenheit, making it the hottest planet in our solar system, hot enough to melt lead. Venus's evolution through time may help us understand how habitability evolves over time, and where we might find habitable planets beyond our solar system. How did Venus form? It is still not known if Venus was bombarded by comets and asteroids rich in water the way Earth was. Understanding the delivery of water to Venus is important for evaluating its potential to host oceans in the past. What is the atmospheric composition of Venus? One of the biggest mysteries of Venus's atmosphere lies in the lowermost or deep atmosphere, where carbon dioxide is heated and pressurized to the point where it acts more like a hot liquid than a gas. The Da Vinci probe will measure chemistry, pressure, temperature, and dynamics at least every 200 meters as it descends through Venus's atmosphere to the surface. How are the rocks of Venus formed? Da Vinci's high-resolution imaging beneath the clouds will test ideas about the role of water in forming what may be ancient continental crusts on Venus at human scales. Da Vinci will study one of these tesserae, Alpha Reggio, to better understand its composition. How much water does Venus have? Liquid water is essential for life. We cannot assess Venus's past habitability without knowing how much water Venus may have had, and when and how it lost that water. Scientists will use measurements of the atmosphere from the Da Vinci probe to explore clues of the story of past water on our sister planet. What is the nature of surface activity of Venus?
Earth's crust hosts a network of relatively thin plates,
Jostling around the planet's surface in constant horizontal motion. If similar plate tectonics exist on Venus, the planet's crust must experience continental drift, like Earth. Another key mystery about the surface of Venus is volcanism. The two upcoming missions to Venus, Da Vinci and Veritas, aim to understand the current volcanic activity of Venus. What do the mountains look like on Venus? Previous Venus landers, Filmora and Vega, have taken photographs of the Venusian plains from the surface, but Da Vinci's cameras will snap the first ever high-resolution aerial photos of a mountainous tesserae surface as the probe descends over the rugged Alpha Reggio Islands region. Are there Venus-like planets beyond our solar system? We will be able to relate what we discover at Venus to Venus-like exoplanets observed by the James Webb Space Telescope. If Venus shows signs of previous habitability, that could mean these exoplanets might be habitable as well. New mysteries we haven't thought of yet. There are many mysteries we can't even imagine right now. With NASA's newest missions to our sister planet, there are plenty of new discoveries to be made. Venus, here we come.